next topic is rotatory motion, rotational motion. So you learned about rotatory motion earlier also, right? Circular motion. In circular motion, you learned about rotatory, what we can say, rotational kinematics. Rotational kinematics means the kinematic quantities like angular displacement, angular velocity, angular acceleration. But these things you learned about. I will revise once. Circular motion, first of all, what is the difference between circular motion and rotatory motion? We learned about circular motion earlier, right? Uniform circular motion, horizontal circular motion, vertical circular motion. We learned these things. Now we are studying separately rotatory motion. What is the difference between circular motion and rotatory motion?
In circular motion, the body moves in
rotatory motion?
The body moves in one axis.
In one axis. So the difference is that only axis. Axis of rotation. Axis of rotation means you know, right? About one point, the body will be moving in circular motion and rotatory motion. And if you imagine a line, a straight line along that, right, that is called axis of rotation, which is perpendicular to plane of rotation. So that axis will be in circular motion. That axis is not a part of the body, but in rotatory motion, that axis is part of the body. For example, you see this fan, the blades of the fan, they will be circular motion or rotatory motion. Circular motion. The disc of the fan, rotatory motion. Like wheel of the vehicle, circular or rotatory. You can say earth motion only. Earth has two types of motion, right? Rotating, revolving. Rotation means what?
The earth rotates on its own.
On its own, about own axis. Revolving means around the sun. So revolving is not rotatory motion. Revolving is what? It is circular motion. Rotation means it is rotating about its own axis. That is rotatory motion. That is the only difference between circular motion and rotatory motion. Like how you can classify or how you can identify which is circular motion, which is rotatory motion means based on that. If the object is moving about a point which is not its part, then that motion is circular motion. If it is its part, a point is a part of its body, then rotatory motion, right? So you can consider angular displacement. Angular displacement means you know, right?
Change the displacement covered, the angle covered.
Angle covered. First thing, rotational kinematics or angular kinematics. You can write angular kinematics. First thing is angular displacement. Angular displacement will write as theta. Right? So, for example, a body is moving in a circular path. Initially, the body is here. After some time, the body has reached this point. And from here to here, about this point, it makes some angle. This is what we call angular displacement. So that is general angle only. So angular displacement, SI unit of angular displacement is radian. Radian, right? Dimensional formula, we don't have any dimensional formula for angle displacement, radian. Why? Because how you got this theta here means this is radius, this is distance traveled. Do you know the relation between these three? Arc length, angle, radius.
S is equal to RT.
S equals to r theta. So theta equals to S by r. S is what? Distance. Distance only. Distance traveled by the body. R is what?
Radius.
That's also length only. So unit of S will be unit of length only. Unit of radius also unit of length only. So the ratio between same quantities. So that's why it is dimensions. It is dimensionless quantity, right? And it radian is a unit, but generally angle will measure in terms of degrees. Right? Do you know the difference between relation between radians and degrees? Relation between degree and radian. Degree and radian. Generally 360 degrees equals to 2 pi radian. Right? 1 degree will be 2 pi by 360 radian. Or pi by 1. 1 radian will be 360 by 2 pi degree. Right? So by this relation only we got pi by 4 as 45 degrees. You know the relations like pi by 3 means 60 degrees, pi by 2 90 degrees, 3 pi by 4 145 degrees. Right? By using this relation only we got those values. So this is one about angular displacement. This angular velocity, if you see, angular velocity will write as omega. Like linear velocity only, but it is the velocity of a body which is in a curved path. Curved path means maybe circular or rotating. So we know linear velocity. How you will define linear velocity?
Change in displacement by time.
Formula is displacement by time. Definition is rate of change of positions or rate of change of displacement. So it also defined in the same manner. Rate of change of angular displacement. Angular displacement. So omega you can write as d theta by dt. D theta by dt. Right? So SI unit is what? Radian per second. Dimensional formula. Radian don't have any seconds. So it will be n power 0, L power 0, T power minus 1. That is the dimension formula. And more if you want to discuss about angular velocity further. Like linear velocity. In linear velocity you have 3 types. Right? Like instantaneous velocity, average velocity, uniform velocity. Instantaneous velocity means velocity at a particular instant. And instantaneous velocity defined as v equals to ds by dt. Right over. Here also, and instantaneous angular velocity will be instantaneous dt by dt. Average
Theta 2 minus theta 1.
change in angle by change in angle, the total angular displacement by total time taken. Total angular displacement by total time. For example, we'll draw here. body initially here at theta 1 at A. After some time it reaches here B. This angle is theta 2. What is the angular displacement now?
T2 minus T2.
Theta 2 minus theta 1. Right? This is the angular displacement, no? From here to here. So this is theta 2 minus theta 1. So average omega average will be what? Theta 2 minus theta 1 by t. Total time period. Uniform angular velocity means, say if it is constant, the angular velocity is called uniform angular velocity. So this is about angular velocity. We discuss about angular acceleration. We have one more formula for angular velocity. For example, angular velocity is the total angular displacement by time period. For example, I'll draw here. Complete here omega equals to angular displacement by time period. So if it is completed one circle in one complete cycle or in complete rotation or revolution, whatever you say, theta will be what? 360 only, it won't be 0. Right? Then there will be no difference from initial position and final position. No? Linear displacement will be 0, but angular displacement won't be 0 because it has traveled through certain angle. So it will be 2 by, what is the time taken? It is called time period. Time period. Time period is what? Time taken to complete one rotation. Time taken to complete one rotation is called time period. So we write this as time period. Right? So this is also one more formula of omega. Or you can also consider this as relation between angular velocity and time period. And further, we use in many cases this formula. Next, angular acceleration. We write as alpha. Angular acceleration is alpha. This is also defined as rate of change of angular velocity. Right? Rate of change of angular velocity. So alpha we can write as d omega by dt. Right? Omega again in like linear acceleration, in angular acceleration also we have different three types. What are the three types? Instantaneous angular acceleration, average angular acceleration, uniform angular acceleration. So this is instantaneous. d omega by dt. Average will be what? Change in angular velocity by total time. So that will be omega 2 minus omega 1 by t. Uniform angular acceleration means angular acceleration is constant. Right? SI is radian per second square. There meter. There near radian is there. That is the difference, right? I mean, not saying. Dimension formula is m0 L0 t power minus 2. Right? These are the dimension formulas. So this is about angular displacement, angular velocity, angular acceleration. Right? You want to copy or? No, So next topic, this is also you will learn already, I think. The relation between linear quantities and angular quantities. Do you remember? Relation between linear, angular, kinematic quantities. What is that? Linear and angular. For example, if you consider displacement, linear displacement and angular displacement. Linear displacement is what? S we represented as angular displacement is theta. So we discussed earlier, right? Relation between linear displacement and angular displacement. S equals to r theta. S is linear displacement, theta is angular displacement. So this gives a relation between linear displacement and angular displacement. So from this, if differentiate both sides d by dt with respect to time, d by dt of r theta. So ds by dt is
velocity.
linear velocity or linear speed. This one r will be constant because it is radius of circle is constant. D theta by dt. So d theta by dt is nothing but omega. So this is the relation between linear speed and angular velocity. Again, if you differentiate this, d by dt is acceleration. So this r into d omega by dt is alpha. This is the relation between linear acceleration and angular acceleration. But which acceleration it is? In rotating motion or circular motion, we have three different accelerations. Do you remember? Centripetal acceleration, tangential acceleration, net acceleration. This is angular acceleration, that is different case. This is which acceleration? Tangential acceleration. Why? Because this is due to rate of change of speed. Right? Centripetal acceleration means that is due to the change in direction. Right? So tangential acceleration is dv by dt, centripetal acceleration v square by r. Right? So this is the relation between linear acceleration and angular acceleration. Right? This is one topic. Other one is equations of motion. You remember that? Equations of motion. Equations of motion. These are valid if you go to translated motion or linear motion. Equations of motion are valid under constant acceleration. So here also the angular acceleration can be uniform. When the angular acceleration is uniform, then you can derive equations of motion for angular motion also, for rotatory motion also. Now, in linear motion, we have three equations, four equations. One is v equals to u plus at. Other one is s equals to ut plus of at square. Next one is v square minus u square equals to 2as. What is the next one? Sn equals to u plus a into n minus 1 by 2. This is displacement in nth second. Right. So it will be transformed into angular kinetics. Like v will be replaced with omega 2 final angular velocity. U will be replaced with omega 1 initial angular velocity. S will be replaced with theta. A will be replaced with alpha. T will be replaced with T only because there is no different rotational time and linear time. Now you can write this in place of V. Omega 2 equals to omega 1 plus alpha t S is theta equals to omega 1 t plus half alpha t square. Next to v square minus u square. V is what? Omega 2 square minus omega 1 square equals to 2 alpha theta. Next one is theta n equals to omega 1 plus alpha into n minus 1 by 2. Right? So these are the equations of motion in case of rotatory motion. Right? So there is one question given. You read the question. A circular disc is rotating about its own axis at uniform angular velocity omega. Uniform angular velocity. The disc is subjected to uniform angular retardation, by which its angular velocity decreased to omega by 2. So it is subjected to, it is an exercise. It is subjected to uniform angular retardation, so that the angular velocity decreased to omega by 2 during 120 rotations. 120 rotations, right? Then the number of rotations further made by it before coming to rest. Do you understand the question? First you need to understand. The question is like this. There is a disc, it is rotating with omega. Now you apply some external torque or something by doing something, some external, it is subjected to angular retardation, constant angular retardation, so that in 120 rotations the velocity become, angular velocity become omega by 2 after 120 rotations. Now the question is, how many rotations will it take further to become at rest? To come to rest, how many rotations further it will take? Right? That is the question. So how will you do? So same question if you given a linear motion, what you will do? For example, a body is there. It is moving some velocity, retarding force is applied. A body is there, it is moving some 20 meters per second, right? After some distance, it becomes 10 meters per second. After what distance, it will come to 0. This is a question given in linear motion. How will you solve? Here in both the cases, what is constant, what is same? This and this. Retardation is same. Right? We have initial velocity, final velocity in this case, and displacement alpha you need to find. This formula we use. Here also same thing. We don't know S. Here you can find alpha. So here you know initial velocity, final velocity, alpha you know, S you need to find. So here also we use the same formula. So in case 1 what happens? Or else we will write initial angular velocity is omega, final angular velocity is omega by 2. Theta equals to what? They have given n, 120 rotations. So theta will be what? In one rotation, angular displacement is 2 pi. In the 120 rotations, 120 into 2 pi. So that means 240 pi radian. Right. Now, is there any other shortcut to find? First we'll find alpha, then we'll substitute. So alpha will be what? Omega 2 square minus omega 1 square by 2 theta. Omega 2 square is what? Omega by 2 whole square minus omega square by 2 into 240. Omega 2, actually it is retardation only, so we'll get a negative, no problem. So this is omega square by 4 minus omega square whole by 480. So this is minus 3 omega square by 4 into 480. So this is alpha. So let it be like this. In case 2 will be what? In case 2, omega 1 is omega by 2. Omega 2 is, it should come to rest. Alpha is just 3 by 4 omega square by 480 by 3 by 4 into theta. How many rotations you need to find? Okay. So that we'll see. First you find theta, then how to find n, that we'll see. So theta equals to what? Omega 2 square minus omega 1 square by 2 alpha. 2 alpha. Omega 2 is what? 0 square minus omega 1 is? Omega by 2 whole square by 2 into alpha is what? Minus 3 by 4 into omega square by 480. So minus omega square by 4 into these things we take up 4 into 480 by, I forgot, by minus 2 into 3 into omega square. So omega square will cancel. 4 get cancelled. 6, 8, 80. So this negative also get cancelled. 85. Theta equals to 85. How to find n?
N is equal to theta by 2 pi.
Theta by 2 pi. That's only n. So theta, here the relation is theta equals to 2n pi or n into 2 pi. Right in that manner, n into 2 pi. Right? So n equals to what? Theta by 2 pi. So n equals to theta by 2 pi, that means 80 by 2 pi, that means 40. So how many further rotations is required means 40. There is no way to solve this kind of question, right? So one more question they are given, like angular displacement of a particle is given by theta equal to t square plus 2t radian by t in second from the angular acceleration of the particle after 2 seconds. So they given angular displacement as a function of time. Angular displacement, angular acceleration at 2 seconds thereafter. So what will you do? Given theta equals to t square plus 2t. Now you find the question?
No, sir.
T cube plus 2t. No problem. So we need to find angular acceleration. Alpha equals to what? We know d omega by dt. When it is given as a function of time, we use differentiation. That same thing we done in linear motion operator. But omega, we don't know. Omega equals to what? D theta by dt. D theta by dt. So d by dt of theta is what? T cube plus 2t. That means t cube differentiation is 3 into t square plus 2t differentiation is 2. So this is omega. Alpha will be what?
d
d omega by dt. That means d by dt of 3d square plus 3d square will be 60
60
plus 2 differentiation is 0. This is alpha. We need at t equals to 2 seconds. Alpha will be 6 into 2, 12 radian per second square. Right? So this kind of questions will be asked. One more question they asked. A disc of radius 0.1 meter starts from rest with an angular acceleration 4.4 radian per second. Angular acceleration 4.4 radian per second square. The linear velocity of the point on its rim after 5 seconds. After 5 seconds, we need to find linear velocity. What they have given? Radius they have given. Angular acceleration they have given. The question is, so alpha is given. So the question is, there is a disk of radius 0.1 meter. Alpha is how much? 4.4 radian per second square. After t 5 seconds, we need to find speed at rim. Speed of the particle at rim. Right? So, speed means linear speed or angular speed? Linear speed. So, linear speed, how we can find? V equals to R omega. So, first we need to find omega. R we know 0.1. So, our task is to find omega first. So, it is starting from rest, right? And it starts from rest. So, initial angular velocity equals to 0. Right? Omega 2 we need to find. Omega 2 formula is omega 1 plus alpha t. Omega 1 is 0. Alpha is 4.4 into t is 5 seconds. So 4.4 into 5. 22. 22 radian per second. But we need V. V equals to R omega. R is 0.1 into 22, that is 2.2 radian per second. Sorry, meter per second. Right? We will find it. In part 3, rotational variables, relation between linear and angular variables.